You can all hear me. I was just going to say I was looking at the messages coming through, and it seems that most of you are in Europe. I saw Belgium, I saw Israel, I saw quite a few Italians, so buongiorno to the Italians. But I think just to cover every eventuality, I'll say good morning, good afternoon, and good evening. And also would like to say that in these very difficult times, we're all suffering from a big change in our personal lives. Everyone on this call has that big change, but very, very many of you on this call have a big change in your businesses and your business lives. And I have a great degree of sympathy for that. And as a company, we're trying to do everything we can to help you. And one of the things we can do to help you during these difficult times as you think about how you're going to go back into your practices and how you're going to care for your patients is perhaps to put on presentations like this. And I hope you had the chance to listen to Phil Morgan recently talking about COVID-19. I thought it was an exceptional presentation. So what I'd like to talk to you today is about, as you think about how you go forwards caring for your patients, how you might take the performance of your contact lenses up to potentially a new level and delight your patients, work to retain them within your practice, and let's be frank, also maybe by upgrading them, enhance your practice revenue after a very difficult period of closure. So I want to talk to you about, firstly, the contact lens that you and your patients can trust, and specifically look at daily disposable lenses as a potential way of delighting your patients and enhancing the performance they get from contact lenses. So when we look at daily disposable lenses throughout the region, throughout Europe, we see some very significant differences between various markets. We see that the UK, over the years from 2016 to 2019, has had a very high value share of daily disposables compared to reusables. That's not the share of patients, it's the share of value. So the patients will be less, but still the overwhelming, it's still a majority of patients. The same in Russia, in UAE, and then you see in Russia and Turkey a much lower usage of these lenses. But what you see in all of these markets is an increase over the past few years, and that's reflected globally. So we see that in the United States, we see this in Asia Pacific, this growth in the prescribing of daily disposables. When we look at the particular material type by those same markets, again shared by value, we again see very significant differences. We see that in the UK and in Russia in particular, the overwhelming majority of patients are being fitted with silicone hydrogel daily disposables, whereas in Turkey and the United Arab Emirates, the majority have been fitted in hydrogels. And are some of these practitioners right in doing that? Are some of them wrong? Or is the truth, as I hope to show, or the balance, that we need both of these material types to delight our patients and give them the best possible performance? Whichever material type we fit, I think we can all agree there are very significant benefits to daily disposables. And forgive me if this is obvious, but this is kind of to level set us in what those benefits are. To our patients on the left of this slide, it's all about lifestyle. And daily disposables provide many lifestyle benefits to those patients. Obviously, they're convenient. It's one less thing to have to do at the end of the day, cleaning and disinfecting your lenses after use. You will always have a supply of spare replacement lenses. If and when we go away for the weekend again, we just take a strip of 5 lenses and we have 2 spare for a weekend away for each eye. And they're, of course, an ideal choice for part-time or occasional lens wearers, those wearers who wear them at weekends, socially, for sports. A great choice for those. As clinicians, clearly the clinical benefits on the right of this slide are very important. We know, and I've put numerous references on this slide, but there are many more I could have put. We know that daily disposables result in an extremely low risk of adverse events. There's significantly less spoliation from any lens deposits on those daily disposables. Now, deposits in themselves are not bad. If the deposit is protein or lipid from the tear film, and it's on the lens, that is not necessarily bad, and recent research has shown this. It's if the deposits become degraded, denatured, oxidized, that's bad, and that's less likely to occur on a daily disposable than a reusable lens. Obviously, we avoid the use of any interaction between the contact lens solution with the eye, with the corneal epithelium or the tarsal conjunctiva. Now, contact lens solutions have improved very much in recent years, but still there's a body of evidence that shows removing the solution and using lenses as single use delivers better results for patients. Now, it appears from research that daily disposable wearers are more compliant, and that's a great thing. But I do think it's useful to compare their stated number of days a week they wear the lenses with their consumption, just to be sure they're compliant. And what we've seen with daily disposables, when we take a lens, a reusable lens, as I'll show you in a moment, and we replace it daily, we get a better performance in terms of comfort. And we've certainly seen two brands of daily disposable lenses, two hydrogel brands, associated with relief from allergies. And I'm beginning to feel that we're going into allergy season now, starting to get a little bit of itching. And that's a significant thing for our patients across the region. Now, when we look at what are the factors that drive the performance of a contact lens, and I'm showing them in this schematic here, there are some people who give a very simple message. And I'm trying to be polite here, a message that is a little economical with the truth. They will say everything is about oxygen transmissibility, dK over T. So you should only fit daily disposable silicone hydrogels because only they have the oxygen transmissibility that will give ocular health. They'll also say they'll give you better comfort and that will, delight your patients. I'm afraid the peer-reviewed evidence for that point of view is not there. The marketing story is very simple if we say everything's about oxygen, but actually it's more than that. It's about the other things you see on this schematic, on this diagram. It's about modulus. It's about wettability. It's about how is the lens designed. It's about UV blocking, and it's about, as you'll hear in more depth from Smuel, it's about coefficient of friction. And all of those things ladder up to deliver what patients need and what we need as clinicians. Comfort, which is the biggest reason for dropout. Vision, which is another major reason for dropout or stopping contact lens wear. And finally, health, which we must be overwhelmingly concerned about for the benefit of our patients in the short and the long term. So let's look at some of those factors. Let's start with modulus. Now this slide on the left shows data of the measured moduli for a range of contact lens materials. And the moduli of contact lens materials varies widely between the first introduced silicone hydrogels in 1999, and the example there I've put is the Pure Vision lens, which has a modulus, I think, of around 1.5. And then you see towards the left of that graph a range of modern silicone hydrogels which have pretty similar moduli. And an important thing when you're looking at the modulus of elasticity or the stiffness of the lens is that the data comes from the same methodology, because there is no accepted standardized methodology for measuring modulus. So all of these results were taken in the same experimental series using the same apparatus. So what is the relevance of modulus? Well, Noel Brennan, in a series of carefully controlled clinical investigations conducted at his then research centre in Australia, looked at the relationship between modulus, which is shown on the right of this slide, towards on the x-axis. He looked at the relationship between modulus and comfort, end-of-day comfort. And you can see how that on the extreme right of this graph, you've got a lens with a modulus of 1.5 with a relatively low end-of-day comfort. But lots of lenses on the left of this chart show a similar level of modulus, but differing levels of comfort. and that's the first kind of point I want to make, is that you can have lenses with a similar modulus, but they have different levels of comfort. So there must be other, perhaps more important factors, and the correlation coefficient here is relatively low. So the relationship between modulus and comfort is not very strong. When we look at other factors, something which is often not considered very much by speakers perhaps, is the thickness distribution through the contact lens. So we know from work that Nathan Ephron did in the mid-80s that if you take a lens with all of the things being equal, a lens with a thin center and a relatively uniform thickness profile, so a well-lenticulated lens, you will have better comfort. And that's when you look at lenses from all of the different manufacturers. We all aim to make our lenses as thin as we can and still handle well, and as uniform in thickness as we can by careful lenticulation. But there's a further factor that really is critically important, and it's been shown by the study I've cited here from Michel Guillon's group, but others have shown the same results, and that is that the edge thickness and form is critically important. And if you look at the diagram on the right of this slide, and you look at the way the lens tapers down to an incredibly thin apex, which is actually resting on the conjunctival surface, then this form of edge has been shown to be more comfortable, all other things being equal, than the kind of rounded edge which you see on many contact lens products. So thinking about the edge is also very important when we think about what lens to fit to our patients to deliver comfort, vision, and health. But there's a factor that is overwhelmingly important in terms of material properties, and that is the coefficient of friction. And our understanding of coefficient of friction has grown immensely in recent times. Like modulus, there's no standardized methodology for looking at this, but the next speaker, Dr. Samuel Tosatti, has been instrumental in driving the science behind this forwards. And what this slide shows, with the data from Noel Brennan's same multiple control studies, is that lenses with a high coefficient of friction, and that is lenses to the right of this diagram, have very consistently less end-of-day comfort than the lenses clustered to the left of this diagram. And you'll see there are 5 lenses that have a similar coefficient of friction, and they all have a similar level of end-of-day comfort. So this is the material factor, and this has been endorsed by the TFOS group led by Lyndon Jones and other researchers who looked at the factors that drive contact lens comfort, and the one that they identified as being the most strong factor was coefficient of friction. And to learn more about this critically important factor, let me now hand over to Dr. Samuel Tosatti, who is based in Switzerland. Switzerland being famous for many things. I put chocolate top of my list, but as a member of the contact lens fraternity, I'd also say Switzerland is incredibly famous for its precision engineering, its precision science, and its attention to detail. So over to you, Samuel.
Thank you, Dave. Good evening, everybody. Schönen Abend, I would say, as we say here in Zurich, and thank you for the kind introduction. So I think in this day where everything doesn't move so smooth, and so things everything stick, talking about tribology, it's maybe give someone an idea how to look at different things. So let's see. Yes, what is tribology? Tribology is the science that study the relative movement between two surfaces, and probably not everybody is aware, but so we need sometimes friction, not necessarily between people, but so we need, as example, friction between our car and the road, or we need the friction to make the fire. Even in the modern light, and is all about friction. We need to reduce friction to win a race. Coming from Switzerland, so it's kind of a national proudness of this. And at the end of the day, we need friction also in biology. And maybe again, just try to explain it very basic. So friction is the resistance against motion. If there would be no friction, if I push something, that will go forever and ever. But the friction is the main responsible for things to get stuck. Okay. When looking at friction, I need a few key components. So there is what is called the normal force. So is, as example, the weight of a crate which has to be shifted. The weight is mass times the acceleration, so it's a force, okay? And this is a kind of particularity of the surface. It can be also be the way I press more or less against the surface. So pressure can also be correlated to converted to a force. On the other hand, we have what we call the lateral force. So it's the force which I measure as a result of friction. If there is friction, I have a force that goes opposite to the movement. So the coefficient of friction, which has been described before by Dave, is nothing else as the relationship between the lateral force and the normal force. So I have a certain normal force, I measure a lateral force, and divide one number by the other, I got a friction coefficient. If I increase my force, I expect an increase my normal force, I expect an increase in the lateral force. So the coefficient of friction can also be seen as the slope of a linear regression between the normal force and the lateral force. You see here depicted in a graphical way. The most important things for everybody to understand is that the coefficient of friction, it is not a material intrinsic properties. It is not like the modulus. So if someone is hard or is soft, is hard or soft. But if someone is those days rough, can be due to the daily humor, and if he has not slept the night before, and it's not an intrinsic property, maybe the day after is different. So it's a property that depends on the situation, depends on the two material and the situation where they are sliding against each other. We can have high friction, so in this case, by the same lateral force, normal force we measure different. We can have low friction, like when we add oil against two surfaces, they start to slide, and so that's why we decrease the friction, although the situation and the material that move are exactly the same. We are all lubricated, otherwise will not work. Two examples are the joints. In every one of our joints, we use water, which is a little bit strange because if you imagine what engineers use oil, so VD40 as an example of everything or lubricated, but no one of us is VD40 lubricated. We are actually water lubricated. The joint is an example. Food and salivary glands is another example. So without the protein in the saliva, the food will not move forward. That's kind of one point. So, and another example where friction plays a very critical role is when we look at blinking. So when we look at the eyelid moving against the cornea, and there we have a very typical tribological situation where we have one surface moving against another surface at a different speed, at a certain pressure, which is the kind of the pressure given by the form of the eyelid. We have a lubricant, we have a complex lubricant, we have a water, we have proteins, we have lipids to prevent that this lubricant evaporate, okay? and we have glands that produce this lubricant that ended up on another surface. That's kind of the whole situation in the eye. So it's just not a little bit of tears and that's it. So it's a complex, continuously evolving dynamic situation. And so talking to this audience, so mentioning dry eye is to me an example of a failure of these complex lubricating system as example. When we were being asked almost 12 years ago to measure the coefficient of friction of contact lens, I say the first time I say, oh, easy, no problem. Then we went 2 or 3 times against the wall, and then we start, okay, to think, and at the end we managed to find a situation, and we had to concentrate it to several aspects, and actually we put particularly attention to 2 levels. One is the environment where I'm doing the measurement, and the other one is the counter surface. I need a mechanical engineered system that mimics the situation in the eye. So tears was the first important thing, and the second important thing was the counter surface. Tears, we find a solution over the year in collaboration with Johnson & Johnson to mimic and generate what we call tear-like fluid, so a fluid that simulates tears, and we can get it in liters, okay, and not in microliters. And the counter surface, we really try to develop something that mimics the surface of the eyelid. So it should have mucin being the most important protein to in this relationship, they have at least a layer of mucin on the surface. And this is what we did. We had also the possibility of using an instrument which has the right forces in the right dimension. That was another combination. So it's nothing else as a very sensitive spring. You see it here. You see the glass which we use, okay, which was coated to mimic the eyelid. We also introduced from the beginning, in a very simplistic, engineered way, not only the data out of the blister, but also a way to simulate the end of day. So you measure by comfort, or people measure by comfort, the end of day. So we also wanted to say, oh, we would like to measure this situation. So what happens to a lens after it has been around for 1 day? And in the simplest manner we did is just we were trying to say, okay, when the eyelid is closed, it's completely wet, and when the eye is open, I have just a thin film that tends to dry out. We neglect the mechanical part, but at least the presence of this continuously replenishing tear film was something that we mimicked over a period of 18 hours to do that. And result, we investigated a lot of lenses. In the add-on session, I can provide you some reference where to find this data. But so we were measuring daily disposable and reusable lenses. We were measuring them out of the blister and after cycling, and we see really that there is a full change in the coefficient of friction from lenses which are very low. So we are talking about in our situation a coefficient of friction of 0.015. It's not not an absolute number, it's a number, and we got numbers that were around 0.38, so something like 20 times higher or 30 times higher in the number. So at least we see a difference between different material and different lens geometry and architecture. Okay, and these helped to generate this database that then the people correlated to comfort. And again, I'm just saying, we measure coefficient of friction, we measure the friction between simulated always the same surface as simulating the eyelid and the contact lenses which varies, and where the variable. Okay, and we got numbers. They were varying by a factor of 30 among each other. One question was, sooner or later, how do those numbers fit in absolute? What does it mean 0.015, which I was telling you? And to do that, we were using, or we started a series of experiments where we were using human cornea as a reference. That's our kind of gold reference. Can I measure my simulated eyelid against cornea? And what kind of number would I get? We did that in a study in Portland, Oregon, together with the Lion Vision Gift. It's and sponsored by Johnson & where we were measuring fresh cornea from donor. So actually it was cornea which could not be used for transplantation, from fresh within 7 hours from death to enucleation, so very, very fresh system, and we try to get numbers out of it. Okay, I'm not, these are all the different knockout and condition for the experiment. I think important is that it's just as we go there and start measuring eyes like this. So we have been first working with rabbit, and we have been working with preserved human cornea just to establish the protocol. So we are not so just go and measure, okay? And here you see a little bit the setup. So we really cut off a form of the cornea, almost like the contact lens. We put on a holder that on the back side was kind of formed to better fit the cornea. Is much thicker than the contact lens, but otherwise was a setup similar to the one we used to the contact lens, and put in our instrument and measure that. Okay. The number that we get out varied between 0.005 and 0.025. So if I compare with the best-in-class lenses we were looking, so we see that the coefficient of friction of best-in-class lenses is similar and to the coefficient of friction of human cornea. So at least we have a connection point. In summary of these things is that there is a correlation between contact lens friction, so the how much resistance is against the closing of the eye, and the clinical performance. We try to develop a method which is as robust and as simple as possible. At least was also thought to before going too expensive or before going to the hospital, maybe one can check this as a quality control. If the lens is very high in friction, maybe we should go back and define new lenses. Okay, we simulate the wear, so just that we have an idea as a prediction of the end of day comfort, and we compare those values with the one of human cornea. We brought a little bit further, and this will be in the add-on session, which is in principle how much does it mean? I talk you in terms of work. How much does it mean in terms of fatigue? This difference in the friction, and can I correlate kind of again, think about the crate to be pushed. Okay, how much more fatigue does it make the eye at the end of the day by selecting one or the other lenses, and try to put that in a more absolute content. But this we can talk later on, or I'm happy to give answer to questions later on. Otherwise, at this point, I will pass back to Dave, and for the other parameters. So coefficient of friction is not everything; it's one of many key parameters.
Thank you very much, Samuel. I've been watching the messages coming through here, and there are a number of people who are saying they can't hear what we're saying. I think, and I communicated to Milos, who's running this session, I think the likely problem is because everybody's working from home. Internet connections are not as robust as they normally are. Mine is fine. If you've got lots of kids in your house downloading videos and all sorts of things, stop them so you can listen to us. This recording, I believe, is being recorded. So after this, there will be an email sent out that will give you a link if you want to watch this again if things haven't been working for you perfectly. I'm going to carry on now and talk a little bit about oxygen. There's a lot of things that are said about oxygen that are not entirely accurate. The first thing is that if you have a thin mid-water content lens, like the Etafilcon A lens, one day AccuView Moist, then if you look at the most recent research, and there are 4 or 5 different publications that show the level of corneal swelling with this product in daily wear, obviously not overnight wear, this lens, which has a central DK/T of 25.5, shows in this study, which is a study from Lyndon Jones' group, the core group in the University of Waterloo, the graphic you can see here shows, and let me just get the pointer, this shows, as you can see, the differences in 4 different locations in either somebody who's just removed a silicon hydrogel lens, which is the left of the displayed results, compared to the same group of patients refitted into an Etafilcon A mid-water content hydrogel lens, and the differences we see here across the cornea, measured with a very precise technique, show no clinically significant differences in the level of corneal swelling. And also the same researchers looked at limbal hyperemia and found no clinically significant differences. Noel Brennan, again in his series of investigations looking at what factors drive end-of-day comfort, found absolutely no correlation between DK/T and end-of-day comfort. And this has been confirmed by other papers and published research from authors like Michel Guillon. So a message here is that we shouldn't be wary of taking people from maybe a reusable silicone hydrogel, these were presbyopic patients, and refitting them with a daily disposable hydrogel. We're not doing something inherently bad for these wearers, and there's nothing inherently bad about leaving people in daily disposable hydrogel lenses who are getting great clinical results. Let's now look at safety. That must be uppermost in our minds as practitioners. And, you know, the rate of infiltrative events that may lead to a practice visit or a red eye or discomfort is of importance. And what we know as looking at clinicians is that we don't generally see red eye incidents in daily disposable wearers unless they abuse their lenses. And what we know from the research that's been done in this area is that there's a very good body of evidence now that there's a very significantly lower risk of these events occurring in daily disposable wearers compared to reusable wearers. And when we look at a groundbreaking clinical study, a registry study, where a leading researcher in the US called Robin Chalmers looked at a very large number, over 500 wearers of daily disposables, and charted and reviewed their experiences over a year of wear, she found in this study that the very lowest level of adverse events occurred in wearers of daily disposable hydrogel wearers. Yes, the results were very low for silicone hydrogel daily disposable as well, but actually the lowest rates were in hydrogel wearers. And this has been confirmed by work done at the Brian Holden Research Institute in Sydney, Australia, by Jenny Dieck, who also looked at adverse events and infiltrative events and found the only lens that had the lowest rate, i.e. 0, adverse events was a hydrogel daily disposable, namely one day AccuView Moist. And in a further analysis of this study, Robin Chalmers found that actually when you look at teenagers, which probably is the group we'd be most worried about in our practices, she found absolutely 0 infiltrative events in the hydrogel daily disposable wearing group over this 1-year observational study. So from a safety perspective, daily disposables have a really good profile to confirm that it's a very, very sensible movement forward to start fitting more daily disposables in your practice. What about comfort? This is a really interesting study. In this study, these researchers out in, again, Sydney, Australia, they looked at a material, Senafil-Con-A, which is the AccuView Oasis material. And at the time they did this study, that was only available as a reusable. And what they did is they took a group of patients and they did a 3-month study on nearly 300 individuals, some of whom wore this lens as a daily disposable, some of whom wore it as a reusable, either using multi-purpose solutions, as you see, if I can drag this to the right place, as you see here, or hydrogen peroxide solutions. And they looked at 3 things that are all of relevance to us in clinical practice. They looked at the initial comfort, which is what we see with the patient in the chair. They looked at end-of-day comfort, which is something we really need to ask our patients about, because that's the thing which can drive dropout, the reduction in comfort through the day. And they asked about dryness, and in this case, the absence of dryness. So a higher bar is better. And for each of those things, they found that statistically and clinically, they got better results when the lens was used on a daily disposable basis. And when you see differences here of 1 point on a 10 scale, that is clinically significant. So this and other evidence says that all of the things being equal, the more often you replace a lens, the more comfortable it will be. Now, if you are going to take one message home, which is a bit of a crazy thing to say since we're all at home, so if you're going to take one message back to practice when we get back to practice, I think this should be the one. Not all daily disposables are the same. This is a really groundbreaking study which Eric Pappas, as many of you will know, is a leading contact lens researcher based in Australia. Eric Pappas presented this study at the BCLA meeting last year, and I just thought it was an incredibly relevant study that should be of interest to everyone. And what these researchers did is they took 3 groups of individuals, a group of contact lens wearers, 200 plus, who were fitted with one of 5 leading brands of daily disposables. 3 of those brands were silicone hydrogels, 2 of them were hydrogels. We don't know what those brands are. We can suspect. We don't know because they were not revealed in the publication, but they were leading brands available in every single country represented on this call. They took a group of spectacle wearers with an up-to-date prescription, and they took a group of non-spectacle wearers, non-contact lens wearers who were emmetropes. And they measured, amongst other things, their reported comfort. And the results are in this graphic, in this graph here, which is a little bit difficult to understand initially. So I'm just going to try and help understand it. The referent in this graph are the emmetropes. We're probably not surprised that people who have no need for a visual aid have very high levels of comfort, both the initial comfort when they wake up, which is on the x-axis, and the end-of-day comfort, which is on the y-axis. So they're the kind of referent. They're the gold standard, if you like. And the researchers compared or created this circular region on this graph, which is clinical equivalence. So if you fall within this region or on it, you have a clinically equivalent performance to the emmetropes for comfort. And you can see there are 3 brands of contact lens that fall either within or on that line. One of them is a hydrogel. You can also see on this graph the spectacle wearers with the red dot here. Let me just move the cursor. The spectacle wearers with the red dot, they are outside of that region, so they have less comfort than the emmetropes, all those contact lens wearers. And I thought that was really interesting. And then you'll see there's one lens here which has a very disappointing performance right down here. And that is a silicone hydrogel daily disposable. So this is my probably most important point. Not all silicone hydrogel daily disposables are equally comfortable, and daily disposable hydrogel lenses can be as comfortable as the best daily disposable silicone hydrogels. So something to remember when you're making decisions about what lens to fit in practice. So to wind up this section, in terms of considering our patients, we need to look very carefully at health. I've said daily disposables result in lower rates of inflammatory events, incredibly low in the study I showed from Robin Chalmers. No differences, no clinically significant differences in edema between hydrogel and silicone hydrogel materials for daily wear. In terms of comfort, we've seen that DK over T isn't related to comfort. Contact lenses are more comfortable in general when worn on a daily disposable basis. Hydrogel daily disposables have been shown to reduce symptoms in seasonal allergies, which are about to start across the region. And we need to consider material technology as well as lens design when we select lenses for our patients when we go back to clinical practice, because not all daily disposables are the same. In terms of vision, vision can be a reason for dropout. It's the second major reason, along with comfort and handling, for dropout. So we really need to address that when we select lenses for our patient. The lens that gives great vision is very important. To give great vision to our astigmats, we should be fitting torics to patients with 0.75 and above levels of astigmatism. And finally, a really, really important point, I feel, is that we really need to address the needs of our presbyopic patients. And there are some really great multifocal lenses out there that do that, and we'll keep them in contact lenses for as long as they want to. And finally here, when we're selecting and we're explaining to our patients the options, please don't do what our colleagues in the United States do and say, daily disposable lenses are $600 for a year. How would you like to pay that? What we do in Europe generally is to present lenses as a monthly costing, but I would even commend presenting it as a daily costing, because many wearers don't wear their lenses 7 days a week. And in this study shown here from Nathan Ephron, he compared the cost of daily disposables compared to reusable lenses and found that for 5 days or less wear per week, it was actually less expensive or cheaper to wear daily disposables. And even for the group wearing them full time, the differences were not great when you factor in the cost of solutions. So I would suggest as a tip to present the cost as a per day figure and equate it to the cost of a cup of coffee or some other frequent purchase that patients make. So that's the section that comprises the updating of knowledge, as it were, around daily disposables, contact lens material performance, etc. I just wanted to spend a few moments talking about the families of contact lenses that we supply to you. And I'm pleased to say our production facilities are going 100% to keep the lens supply to your patients. We make two fundamentally different families of daily disposable contact lenses. And I always say, whenever I present, you should have a go-to lens, whether it's a Johnson & Johnson lens or one of our competitors' lenses, but you should also have a genuinely different lens. And these two families of lenses, One Day AccuView Moist and AccuView Oasis One Day, are genuinely very different from a material properties standpoint. So let's just spend a few moments looking at those. The products on the left are the One Day AccuView Moist family, which is the spherical, the toric, the multifocal. And those are the #1 selling contact lens brands in the world. And for a good reason, and that's because the performance of Etofilcon A has been proven over 30 years. I started fitting Etofilcon A in 1987, which kind of tells you how long I've been involved in contact lenses. And that proven performance has been summarized in a peer-reviewed publication led by Nathan Ephron and the who's who of global research that was published last week on the Contact Lens and Anterior Eye website. So please try and have a look at that. But there's a full range of lenses to satisfy most patients' needs. To the right of this, we've got the AccuView Oasis One Day family, which has never been beaten in comfort. So despite the fact that that family, that material, came onto the market in the 1980s, it has never been beaten in comfort, despite 28 clinical trials being lodged on clinicaltrials.gov. And that lens has been shown to be superior for performance, vision, and handling over and above a leading daily disposable silicone hydrogel. And I just wanted to show the results for that lens compared to that leading, or one of the leading silicone hydrogel lenses out there. So these are results from Samuel's company, Susos in Switzerland. And to the left of this slide, you can see, let me just get my arrow. You can see the results for out of the blister. And remember, Samuel talked about the coefficient of friction of the cornea. Well, that coefficient of friction was of the order of 0.02. And all of those lenses are reasonably, in that ballpark. We've got one day AccuView Moist, we've got AccuView one day, we've got Dailies Total one, and we've got Precision one, which may be a lens that's launched in your marketplace or will shortly. But as we simulate a day of wear over the course of the next few hours, look at the differences. These lenses show very, very significant increases in the coefficient of friction over that period. And maybe that's why when we ask about comfort with those lenses, we find significant differences in the comfort performance, additionally the vision and handling performance in this composite of various questions called the contact lens user experience rating for these products. So there are differences between products. Some of that difference can be down to the coefficient of friction and how it changes through the course of the day. And it's important for us as clinicians to remember, and important for us as clinicians to ask our patients about their end-of-day comfort, about such things as tired eyes and how the performance of lenses may change. And that when we go back into clinical practice, I hope in the foreseeable future, in the next few weeks or months, that we'll be set up to use daily disposables and all of the facilities at our disposal to really delight our patients and keep them in contact lenses for longer and continue to make them loyal to us and loyal to our practice. Thank you very much. We've got 10 minutes left for questions, so I'll hand back to you, Miloš, to take the questions, and then of course we go into the extra session with Samuel.
Absolutely perfect. Yeah, thank you, David. So David and